Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about proportion for healthcare professionals. A direct proportion is basically one fraction or ratio equal to another fraction or ratio. We use proportion when we were solving percent problems. But we can use direct proportion for a number of other types of problems that you might encounter. It's particularly useful when we're talking about solutions and you want to either find the amount of solute or the amount of the solution. So we're going to focus most of our examples on those types of questions. You can use proportion for some other things like drug dosage calculations or unit conversions or IV flow rates. But I find with those topics, it's much easier to use a process called dimensional analysis. So in the next two videos, I'm going to talk about drug dosage calculations and IV flow rates, but I'm going to use dimensional analysis rather than proportion. I'll do a couple of examples using proportion, but I think you're going to see in the next videos that it's easier to use the other method. The key thing when you're using proportion is to make sure that the ratio is in the same order on both sides. So when we're talking about solutions, we'll talk about the amount of solute over the amount of solution. So it has to be in that order on the other side. The other thing is you need to have both of these quantities in the same unit as well as both of these quantities in the same unit. So if you're measuring your solute in grams, it has to be grams for both of them. If you're measuring your solution in milliliters, it has to be milliliters for both of them. So let's take a look at some examples. If there are 4 grams of solute in 25 milliliters of solution, how many grams would be present in 1 liter of solution? So I like doing the order solute over solution. So if we have 4 grams in 25 milliliters, we want to know how many grams, so that'll be my X, in 1 liter. I can't put a liter in for my volume because I have milliliters as my volume unit on this side of the equation. So I need to change 1 liter to milliliters first. So 1 liter is 1,000 milliliters. I like to set up my proportion with the units to start with, just to confirm that all of the units are consistent. Then you can drop the units and just write it with the numbers. To solve this, I cross multiply, so I'll have 25 times X equals 4 times 1,000. Divide both sides by 25. 4,000 divided by 25 is 160. We know that that unit should be grams. So there would be 160 grams of solute in 1 liter of solution. Let's try some more examples. Next question says, how many grams of sodium chloride are required to make 1,500 milliliters of a 1,800 microgram per milliliter solution? Now, if you're not sure how to change micrograms to grams, I direct you to a video that I produced on the metric system for the sciences, and it talks about how you change from micrograms to grams or any metric unit to any other metric unit. So you might need to review that first. So if you have 800 micrograms in 1 milliliter, you want to know how many micrograms in 1,500 milliliters. When you cross multiply, you're going to have 1x equal to 1,200,000 micrograms. And then in order to change that to grams, I need to move my decimal point 6 places. So that will be equal to 1.2 grams. The other option is I could have changed 800 micrograms to start with, and I have to divide by 1,000,000 to do that. So I move my decimal point 6 places. So 800 micrograms would be 0.0008 grams. So I set up my proportion. It's 0.0008 grams in 1 milliliter. So I want to know how many grams in 1,500 milliliters. 1 times x is x. 0.0008 times 1,500 will equal 1.2. You get the same result either way, so it's up to you what you prefer. Either change to the appropriate mass unit to start, or change after. Let's try some more. In this next example, we're finding volume instead of a mass, so we're finding the volume of a solution. So we're asked to find what volume of glucose solution with a concentration of 250 milligrams per deciliter can be made with 5.5 grams of dry glucose. So again, this mass is in milligrams, this is in grams. You can either change this to grams or this to milligrams. You'll get the same result either way. I'm going to keep it in milligrams, so I know that I have 250 milligrams of solute in 1 deciliter of solution. 5.5 grams is equivalent to 5,500 milligrams. So 5,500 milligrams will give me how many deciliters of volume? Once you've set up your proportion with your units, I can basically now ignore my units. And I'm going to cross multiply. 250 times x will equal 1 times 5,500. Divide both sides by 250 to solve for x. And I get 22, and I know my volume will be in deciliters. If it doesn't specify what unit, I can leave it in deciliters. If they ask me to find how many liters, I would just change 22 deciliters to liters by dividing by 10. So again, know how to change from one metric unit to another metric unit. Let's try some more. Another example, much the same as what we've been doing. How many liters of a solution that has a concentration of 100 micrograms per milliliter can be made from 40 milligrams of salt? So this is milligrams, this is in micrograms. I'm going to change micrograms to milligrams. I'm going to divide by 1,000 to remove my decimal point 3 places. So that would be 0.1 milligrams. So my concentration will be 0.1 milligrams in 1 milliliter of volume. If I've got 40 milligrams of my solute, how many milliliters of solution can I make? We can ignore our units. We cross multiply. We're going to get 0.1 times x equals 40. Divide both sides by 0.1. And we get 400 milliliters. Now the question says how many liters, so we need to change 400 milliliters to liters, and we do that by dividing by 1,000. So we can make 0.4 liters of solution from 40 milligrams of salt, and it will have that concentration. I'm going to do an example of a drug dosage calculation using proportion. We're told a 150-pound adult is to be given a medication at a dose rate of 2 milligrams per pound. How many milligrams will they receive? So I'm going to start with this. They receive 2 milligrams for every pound, so for 1 pound. So how many milligrams do they receive if they are 150 pounds? Cross multiply, 1 times x is x, 2 times 150 is 300. So x will equal 300 milligrams. In the last example, we found out how many milligrams of drug a patient needed, but in this question, we're going to find out how many tablets. So we're told the weight of the patient, and we're told the dosage rate is 1 milligram per pound, and then we're told the strength of the tablets is 50 milligrams per tablet. So what we want to know is how many tablets does this patient receive? So what we're going to start with is the dosage rate. So it's 1 milligram per 1 pound. We want to know how many milligrams for 175 pounds. We cross multiply and we're going to get 175 milligrams. Now we need to find out how many tablets. I'm going to use proportion again. I know that there are 50 milligrams of medication in one tablet. So if my patient needs 175 milligrams, I can calculate how many tablets that is. Again, ignoring the units, 50 times X will equal 1 times 175. Divide both sides by 50, and I get 3.5, and that will be tablets. So I had to use proportion twice. Dimensional analysis will make this process easier, but if you prefer proportion, you can certainly use it. Let's take a look at 2 more examples. Our next example is very similar, but we have the patient weight in kilograms and the dosage rate in milligrams per kilogram. This time, instead of tablets, we're giving a liquid, and we're given the concentration of that liquid. So what I'm going to start with is the dosage rate. So it's 10 milligrams per 1 kilogram of body weight. So I can find out how many milligrams for a 90 kilogram patient. Cross multiply, 1 times X is X, 10 times 90 is 900. So the patient requires 900 milligrams of the drug per dose. Now we take a look at the concentration. We know there are 15 milligrams of medication in 1 milliliter of volume. So in order to get 900 milligrams, we need to calculate the volume of liquid. We cross multiply, 15 times X will equal 1 times 900. Divide both sides by 15. And the volume that the patient would get is 60 milliliters. I find this method of doing drug dosage much more cumbersome than doing dimensional analysis, but some people prefer this. So I like to show it both ways, and then you can decide. Let's look at one last example of using proportion. The last example deals with flow rate with IV. If you observed 8 milliliters of fluid flowing in 20 seconds, you might be asked, what's the flow rate in milliliters per minute? So again, we can use proportion. The more time, the more volume. If we have 8 milliliters in 20 seconds, we want to know how many milliliters in. I've got minute, but I can't put a minute here if my time here is in seconds. So I'm going to change 1 minute to 60 seconds. Now I can cross multiply. 20 times X will equal 8 times 60. Then I divide both sides by 20. So my answer will be 24 milliliters in 60 seconds, or in other words, 24 milliliters per minute. So knowing proportion is very useful for a lot of different types of questions, particularly with solutions and possibly with some of these flow rate questions. So practice using proportion for certain questions, and in the next 2 videos, you'll see a more efficient way of doing drug dosage calculations and certain IV flow rate calculations.